right, and so hopefully that makes sense. So what I just did there, try to get clarified a little bit more, is by using that little toggle down there, I was able to select on the specific range of data that I wanted the minimum maximum to be set upon. I can actually also select on a specific number that way, and then just do the statistics on it. So it's usually pretty straightforward. All right, so that's the lab for this week. Just to show you kind of what it's going to look like, hopefully, is if you are using my old setup, let's see on the computer. So I have in all of the teacher folders an Excel spreadsheet, I think, that has my old data from previous years. Oops, shoot, what did I just do? Oh, it went away. So anyway, if you are in, let's see, I apologize if this is a little jerky. All right, so you will see that there's old compiled lab data from previous years. I will encourage you just to open up one of those because it's actually pretty good data. If your groups, of course, everything goes to hell, you can always just use my old data and send that to them. All right, because that does happen. Let's look at the Excel sheet. So the Excel sheet, as you can see here, let me make it a little clearer. All right, there we go. So down here, of course, we have tabs for the 3 different probes. There's one, I think that one says oxygen, right? And of course, we can see what should happen. You can, of course, delete all this information and have the students come up here and put their various concentrations in and various minimum and maximums. I usually kind of help them because they often will make a mistake again in the minimum and maximum. And it should start populating if you use this program that I've kind of set up. I think I already have it divided so that we determine the rate. So it'll calculate the difference, obviously, and it'll divide it by the 20 minutes. I think it's set for 20 minutes. So anyway, you can check that just to make sure. Here's what, again, I had for various different sugar concentrations. You can see, of course, there's the dip. So all of them were, of course, in anaerobic conditions, so that looked really good. Let's move over here to the carbon dioxide data that I had from previous years. This semester, we actually lowered the concentrations just because we actually didn't have enough sugar. So we made them 0.1, 0.2, 0.3, and 0.4. Of course, we're doing a little bit higher. It usually works a little bit more robustly. And here you can really see what we're kind of going for super nicely, is that the monosaccharides, fructose, of course, and dextrose, have a very potent effect on anaerobic respiration rates, meaning, of course, that the yeast really like those monosaccharides and can do it quite efficiently. And then whereas we see the disaccharides, the lactose, the sucrose, are metabolized much more latently. Yeah, anyway, so it's kind of interesting that you can see it. Let's also see if we similar data for the ethanol. We do. Here we can really see that the fructose seems to be really a good substrate for the yeast in terms of anaerobic, and they're producing a ton of ethanol, of course. Yeah, and then it also, there's some variations here, but we could see, some lab groups do better than others, so I sometimes wonder about that in terms of the variability. So anyway, hopefully the students are able to get 3 sets of data, proving, of course, anaerobic conditions, and then showing the ethanol and carbon dioxide productions. And yeah, and I think the lab template's actually pretty straightforward otherwise. Hope you do well with it. If next week lab seems to get a little bit easier for us faculty. May the force be with you all.